Welcome back to our series Hard Math with Kevin. I'm here with our Chief Analytics Officer, Kevin Mabe. Really excited about this video because I feel like this is one that's really nuanced. It's maybe a little bit, if you're like me, it's a little bit challenging to understand the concept at first, but once you understand it, it makes a lot of sense, and you can see how this is incredibly valuable and how people who don't go through this exercise could be led astray by the way that the data looks. So what Kevin's going to do is going to walk us through the time series that we've been going through. If you haven't watched the other episodes, click the link in our show notes here. But he's going to take us through, and he's going to show us how doing kind of a time series of the time series is beneficial to see how two products might be working together or not working together. So I don't know if I've set that up well, but Kevin, I'll turn it to you.
Yeah, that's great. Thank you very much, Drew. So just to recall, we were dealing with a total revenue curve as well as the revenues for two products. One's product one and one is product two. We did a deep dive into product two for forecasting during the last video. And so what I want to do is take a look at, is the relationship between products one and products two. And here are both of them on the same graph, with product one being the blue line, product two revenue being the orange line. And what we could see off the bat is, again, product two had an initial decline in revenue and then it pretty much flattened off. Product one started off pretty strong and stayed strong, and then it's been declining. So you'll see a period of some relative strength earlier in this time series for both, and then you see weakness in both of these time series toward the end. And so what I'm going to say from now on, or at least the next few minutes, is the wrong way to take a look at how these are related. So the wrong way to take a look at these and say, okay, well, both of them seem to have a downward trend, and so therefore they must be, positively correlated, meaning that when one is going down, the other is going down, and vice versa. And what they mean by when they say that is, what they're doing is they're taking a scatter plot essentially of both products. And let me just do a quick one of those for you, where earlier in this time series you have both of them have pretty high values, which is you can see in this area, and then toward the end you have lower values, which you can see in this area. And then when they correlate the two, they basically put a line through it and say, hey, it looks like it's positively correlated. The problem with doing this approach, however, is that it removes the effect of time, which is, again, what I had said earlier, I think the first series, that time can be a problem in time series analysis. So it's discounting the movements over time, and it's also discounting the internal structures of these time series. But this is how most people would say these time series are related. They're positively correlated, and so therefore...
I'd raise my hand.
Yeah.
Looking at that, yep, that's good.
And
I've done my extra step here, and I've shown that it's got a positive correlation, so I'm done.
Exactly. And so what I'm about to show you instead is, actually, let me do this. Let me see if I can go to a website that talks about spurious correlation. The website will link to it, and basically it's showing the same thing. So for instance, this one example is the number of people who drowned by following a pool correlated with the number of films that Nicolas Cage appeared in, and you can actually show a positive correlation of 66%, which actually is pretty good. And so we laugh at this kind of example, but these kinds of examples are not unique in how people approach other things, such as sentiment in the stock market or the number of likes on Facebook with the amount of revenue I'm bringing in. So people use the same kinds of analysis. They laugh at it in one section, but then when they apply it to the business, they're using the same methodology. So it's inconsistent. So what we're going to do instead is show you how to do it more properly. So the one thing to remember is that each one of these time series has its own internal structure. And what I mean by that is if we took a look at when we were forecasting, for instance, product 2, Yeah, there it is. Forecasting product 2. It had some ups and downs, but that was because of seasonality, and there was some relationship between, within the time series itself. In order to produce the forecast, we needed to understand the structure of this time series. Once you understand the structure of the time series, then you can essentially remove the signal from that time series, or remove the structure, and then take a look at what's left over. And that looks like this. So once we account for the fact in product 2 that it was going down and then flattening, you see this little noisy orange line for product 2. Once you do the same thing for product 1, you see this noisy line for product 1, where now I've removed essentially the signal from the time series, and what's left over here, the residuals, the noise, however you want to talk about it, is plotted together. Now, Drew, what do you notice about how these lines appear to relate on this graph?
I mean, this is very, very different, right? They look like absolute mirror images of each other.
Yes, so they are in fact look mirror images, and what you mean by that as well is they look negative correlated, where you're seeing up down up, and then in the other series you're seeing a down up down. You see that across the board. So when you actually produce a scatter plot from this graph, you'll see something totally different. You will see, and I'll just add a little regression line just to show you the negative correlation. You will see that these time series are in fact negatively correlated, and statistically so, not positively correlated like we saw before. This was doing it the wrong way, and this is essentially doing it the more correct way.
Wow.
Yeah. So you're like, well, okay, I don't understand. How is this possible when I saw in this original graph that it was high here and low here, it was higher here and lower here? Well, if you look closely and take into account the fact that product 1 starts high and goes lower, all these little noisy undulations around its own structures are correlated in a negative way. So take a look at this tail end. When orange goes up and down, blue goes down and then up. And so it's opposite related over here. There's some opposite relationships over here, opposite relationships over here. And so what this analysis is showing is that these two time series are doing their own thing, and they're declining in revenue for a multitude of reasons. But what's going on is that they are acting as substitutes for each other. And so they're not only not positively related, they're negatively related, and they're cannibalizing each other. So this is a conclusion that you would get from a proper analysis once you account for the actual time in time series analysis.
Yeah, that's absolutely fascinating. That's really cool.
Yeah.
So, well, Kevin, as always, very, very informative, very helpful, and certainly, take a moment to kind of pause and think about the number of times that I've maybe looked at something and thought that there was a correlation when that was not the case. To your point, we'll make sure that we link to the Spurious Correlations website as well.
Awesome.
That's pretty fun to look through, and looking forward to our next video.
Yeah, thanks again, Drew.